everyone. Thank you. So hopefully you have things that stood out to you prepared. The protocol that we're going to use for our discussion is called Save the Last Word protocol. And in this protocol, we have provided you, well, in our resource folder, we've provided you the full directions on how the protocol is done. It is a series of what they call rounds in which each participant in the group will take a turn in sharing one aspect of the article or reading that was read. Then they would have a discussion around that. And the last word, hence the name, would come from the person who shared the quote or passage. So let me restate that. So what we're going to do when we put you in groups, we're going to put you in small groups. And Christina, we have 7, so we have to do groups of 3 and one group of 4. We'll do that right.
Already done.
Okay, thank you. You're on it this morning.
Once.
So, for example, if I was in the group and I was the first person to go, I would only share where my quote is from. So I would say on page 17, second paragraph, line, whatever, and I would share what that quote is. That would give the other participants an opportunity to find it and read it. I would only share. I would not share why I chose it, why it stood out to me. I would only share the passage or quote. Then each person in the group would share something about that quote. And that last word would then come from the person who shared initially. And he or she would then tell why it stood out to them.
I love this strategy because if you're like me, you share your quote and then you want to explain it right away and tell all you're thinking about it. And this doesn't let you do that. You have to hear other people's thinking first. So it's a great strategy, especially for your talkers in your class, to make them not talk and do some listening for a minute. As Anthony said, we're going to give you a shared folder before the end of the day. And the actual structure, the official outline of how to do this strategy is in there. In other words, you time round 1 for 2 minutes and round 2. And we are not doing it that formally today. We just want you to follow the idea that you can't tell us about your quote until everybody else has shared something first.
Yes, and that way it'll give you that opportunity to hear. And I used to do a presentation, an activity part on hearing versus listening. And this protocol makes you listen more so than just hearing what people are saying. So that's the benefit of it. And
yeah, because that's the other part is after you share your quote and you share all your thinking about it, you stop listening because you're done. I'm done. I'm out. And this forces you to have to stay engaged through the whole conversation. So again, love this protocol. Again, not so much the formality. I'm not a formal kind of person, but some folks like to have really structured routines. So you'll know how to do that if you like that.
Yeah. And so with that said, are there any questions on the protocol? Okay, so after that first round, then the next person would go. They would share their quote, listen to everyone else, and then share why they did it, and so forth. And so we're going to put you in some groups, and they're just random groups, and you will share your thoughts and hopefully take away not only the information you read initially, but information that you heard during the discussion.
I'm going to put about 8 minutes on the clock. Does that sound okay, Anthony?
2, 3, 4. Yeah, 8 minutes should do.
And so what I was going to say is if you're in a group with only 2 people, that may leave you a little extra time. So you can talk bigger about what math mindset you see in your classroom. But do the protocol first. And then if you have extra time, by all means, start a bigger discussion about your class. Okay. Sorry.
At any time. Thank you.
Okay, we're ready?
Yeah.
Okay, here we go.
Hello. Hello. The quote I chose is that students don't know that making mistakes is actually a learning process. They just assume that they're not math people. And I found that on the second page, right column.
Yes, I could see that. Even while I teach kinder, and as soon as one little kid gets the wrong answer, they just clam up and they think they're no good at it. But it's just about the opportunities to give them different ways of solving math. It hit directly. There was a section on page 18 where it shows that a kindergartner went to the mom and said, "Hey, I'm not good at math anymore. I don't like math because it's all about teaching to the test and taking tests and being timed." And it's true because there are district mandated testing, so a lot of times math is geared towards trying to just get the right answer and timing that, and it does start in kinder, unfortunately.
Same here. Once my students find that a problem is hard, they also stop and quit, and they say they're not good. Just like you said with your students, I'm in the same boat.
I don't know if I can walk far enough
Right.
to get to my classrooms and stuff. So, hey, Luis,
Hello.
you guys are all finished up? The rooms are closing, so we're just going to hang out for a few minutes while we wait.
Got it. Thank you.
Yeah. We got 48 seconds. They're in the countdown, Anthony.
Right.
48
Right.
seconds.
I have it open. I have it.
Okay. Just letting you know. Trying to be a good assistant.
You are. You're doing a great job.
Yay.
I was just reading through the article myself, and something that I already had highlighted, but now I can put a star next to it this time.
Welcome back. We're waiting on one room. We've got about 10 seconds. Okay, I think everybody's back, Anthony.
Okay. Yeah, I see. Okay. Thank you all for being back. Now, you've had some good discussions in your class. Can I ask everyone if you would either share something that you shared in the discussion or share something that someone else had? Well, let me start before we get to that. What are your thoughts about what you read, just in general?
I mean, I felt it's okay to make mistake, which we always do in the math class. We always encourage kids to make mistake and giving them more open-ended question. But kids will struggle at the beginning, but that's okay. They learn more from that. And also, we need to have a growth mindset.
Thank you for sharing. Thank you very much. Anyone else? Yeah.
So at the beginning of the reading, it says that they had a lot of research, but it wasn't getting to the teachers and it wasn't being used in the classrooms. And this is my first year teaching fifth grade dual language, and my math skills are not up to date. So I am in the Victorian age, but our school has been using the math workshop model. And with my TKs, I did the best that I could. But now with fifth grade, it's like a lot more work, and it's fun. And one of the new teachers that came into sixth grade says, "Yeah, but when do I go in the front of the class and teach?" And the principal says, we don't do that anymore. That's like, we've been doing that for the last, whatever, 100 years,
Right.
and it hasn't worked. And, we have to change our ways. And I'm not meaning to say I'm really old, but as an old teacher, it is hard to switch. And it's hard to accept, like, okay, but I like it because it puts more on the kids, and the kids are learning from their peers. So I am glad that they changed it, and I'm hoping that all this research and things that are bringing down back to the teachers, back to the classroom, will help us better prepare the students for the future. Because my school is one of the 100 low performance schools, and it's really sad and embarrassing at the same time. But we have to change something to get better results. So I hope it works.
Thank you.
Thank you.
Yes. Someone else.
Oh, so Martina, my school is also one of the 100, and I'm new to LA. And I haven't taught middle school in 10 years, so I was trained in a completely different model on how to teach. So, so I agree with what you were saying. And this definitely reinforced my philosophy on teaching. And, I know what I wanted to say was I'd seen a video about an Asian school where the student who got it wrong went to the board and everyone helped him. First, they applauded his mistake. Then they all worked through collaboratively to help him with the mistake so that he could learn, because it was a collaborative effort that everyone was going to understand it, and it wasn't punitive, and no one felt shame from that. So this really reinforced that practice in my mind.
I appreciate that. And a little later in the session today, we're going to have something that kind of relates to what you just shared, Marie. Anyone else? Anyone else? No. So Christina, there's two things that popped up in the chat.
Oh, sorry. I thought I was on it. Reinforces my philosophy. That was Marie who just shared. Okay. That's awesome. And then I put in the chat Joe Bowler's website. It's ucubed.org. It's got great manipulatives, great lesson ideas. So if you've not visited that before, I put the link in the chat so that you can bookmark it. And then I also wanted to mention, if you are old like me and still use Facebook, my Facebook, I've really cultivated it so that it's almost all teacher stuff. I have a great writing teacher I follow. I have a great math teacher I follow. But Joe Bowler has a math, it's like How to Learn Math is a Facebook group. And so a lot of different teachers post ideas and videos and lesson ideas and worksheets and all kinds of stuff. So if you are using social media, it's probably on Instagram and other places too. I just don't do lots of social media. I try to stick to the one. But How to Learn Math, if you Google that, you may get some additional resources as well. So other than that, I didn't see anything else in chat. So if I missed your comment, please share it. We want to hear from you.
And now I want to just ask, for some of you, share what you highlight. Just, so we can hear it whole group.
Sorry, what was the question?
I was just saying, I was asking you all if you could just share something that that really stood out to you in the article, just so we can hear it whole group.
I kind of really liked, I think it is on page 19. One student comes home, he got everything math right, and he comes and says his parent, I got everything right. So parent said, oh, that means you haven't learned anything math today. So I kind of like it because usually teachers give one particular method and expect students to solve with that method. So which means kids don't get an opportunity to learn. So it's okay to have a productive struggle that kids struggle and they learn different methods. They make mistake initially, but that's okay. That gives them a deeper understanding of it. I kind of really liked it actually.
Thank you for sharing again. Thank you. Anyone else? There's one thing that is it pronounced Chitra?
Yes.
Okay, Chitra and Martina mentioned kind of the same thing. One thing we do know is that as teachers, we typically teach the way we were taught. The way we learned math is the way we teach it. And someone was saying, that they're in the Victorian age, Yeah, many of us, school itself has been the same structure for 300 years here in the United States. One teacher and kids sit in a row, and we've had very little changes of the way our school system is structured. It's still the Monday through Friday. It's the same, 8 to 2:30, 8 to 3 o'clock, or whatever it is. We haven't changed any of those structures with the way our children are demanding that they need to learn. I just wanted to, throw that little part in. But I was sharing with Christina while we were in our breakout rooms that she and I have seen this article, this portion of the article, for at least 8 years. Okay? At least 8 years. And I was reading something that I had highlighted on mine, and something that I already highlighted, but yet there's a portion of it that even stood out even more to me this morning. And so it says, this is on page 18 at the very top. It says, a critical requirement is that teachers offer mathematics as a learning subject, not as a performance subject. And I was like, what? I hadn't highlighted, but that part didn't really stand out to me until just this morning. And that is so true. And we kind of mentioned it earlier. Our children, that apprehension and stuff comes with, this is math, I need you to perform, I need you to show me the right answer. And that just builds up those walls with our students so much. And we have to get it to the point where it's a learning subject. Chitra just mentioned, you have to, if you didn't learn anything new today, it didn't help you. You got to learn, you got to struggle sometime, and that's where the learning takes place. So with
one of my teachers, can I just add something real quick, Anthony? In one of my teacher groups on Facebook, the teacher was saying that at back to school night, she tells her parents that instead of asking what they did today, ask your students either A, what they learned today, or A, what mistakes they made today, to get kids to understand that mistakes are expected and they're going to happen and that they lead to learning. And having parents also start to incorporate that mindset is hugely important. I usually share this story. I taught kinder for a while, and I was at a parent conference, and I was sitting with mom and dad, and both mom and dad told me that their 5-year-old wasn't a math person. And I was shocked. I thought, how do you know what kind of person they are at 5? That's way too early to already have decided that about your child. And the kid was sitting with me because we did student-led conferences. So they heard their parents say that. And I just thought, wow, in kindergarten, you're already putting that on them as a failure or as, part of their character. And I just was like, my heart broke. I tried really hard that year to do a lot of these open-ended, playful, exploratory kind of math things so that they could demonstrate that they could do good math thinking, because of that conversation. So we know that families play a role in that as well. So if you have an opportunity, posting an article in your Schoology group, talking to parents at parent conferences or back to school night, sharing an article like this with the parents to talk about how you're approaching your class is different. That's all important work as well if you feel comfortable and confident doing that.
Thank you. Okay. Are there any comments comments in regards to the protocol that we use? What were your thoughts about the protocol?
I really like this protocol because instead of sharing our own idea first, saying the quote, and instead of sharing our own idea first, we are listening from others. Then towards the end, we are summarizing. So that gives chance for the students or even for us to listen to others, which is an important skill, and then summarize based on everyone's perspective. Even in our group, I was sharing one of the quotes. I was looking at it in a different way, and Miss Marie looked at it in a different way. So at the same time, we got a chance. I think Miss Lopez looked at it in a different way. So we got a chance when I summarized it. I was looking in both the perspective. So that gives a better understanding of what students think.
Okay. Well, like we said, we have provided the breakdown at the way each round should go in your classroom or with the discussion group for you with the full instructions and the time. So hopefully it's something that you all will find beneficial and be able to use in your classroom. I see in the chat.
Yeah, Alisa offered another question to give to parents, which is what question were you asked to solve in math today? Okay. So that's, again, another way to extend beyond what did you do today, which typically gets the response, nothing.
Nothing, right? Right.
And we know that's not true. We know how hard you're working. All right, go ahead. Thank you.
Okay, so I'm going to ask everyone to grab a piece of paper. It can be, it's not, obviously it's nothing you're going to turn in, but I do want you to have a piece of paper handy, and I want you to complete this equation. Okay. Hopefully you've had an opportunity to finish. I actually don't want your answer right now. I want you to tell me what was your first thought when I said complete this equation. Just unmute yourself and just tell me what your first thought was.
I was sorry, please.
You were surprised?
I was looking at the unlike denominator, so my first thought was to make the denominator equal.
Okay. Anyone else?
So my first thought was what I tell my students is that even math teachers hate fractions.
Right?
Okay, Leslie.
My first thought was, why did he say complete and not solve?
Okay. Anyone else? What were your first thoughts?
Can I tell my story, Anthony?
Sure.
This is in the book. It's further into the introduction than you guys read. Anthony and I were reading this book for a professional reading for our department. I was alone in my home, no one else around, and this appeared in the chapter, and it said in the chapter, solve this problem. You guys, my hands got sweaty. I was by myself reading a book. There was zero pressure. There was no reason for me to have that kind of physical reaction. But literally, my hands got sweaty. I had to put the book down for a second. That's how nervous fractions make me. Because I know there's a way to do it. I know there's a formula, but I don't know it well enough to just be able to whip it off. I would have had to look it up and it scared me. So even adults, even math teachers hate fractions or get nervous, around these concepts.
Yeah. And so another thing, anyone else? Any other comments about this before I start talking? Because I do want to hear from you all. But one thing we typically hear is a little anxiety. Did anyone feel a little anxiety when I'm other than Christina? Okay. Alyssa said, yeah. So it's that same thing our students get, especially when I didn't set it up. I just threw it at them. And, of course, as a good teacher that we all are, we wouldn't necessarily, hopefully, not do that on a regular basis where we just throw something at our children without any warm up, some lead in to get them to think back. Because most of our children, if we've already taught fractions for those who are learning fractions, and then even our older children who we would hope have already learned fractions, we need to do that leading, because sometimes, with our curriculum in our schools, you'll teach something and it's almost in isolation for a while before it resurfaces. And so our children probably would know what to do at this point, but yet if we just throw it at them, like Christina said, they may clam up or feel that anxiety. So what I would do instead would start a discussion. And my first question would be to the class, what is something that we know about fractions? And what could some of my possible answers be?
That we use fractions to share.
Okay. And I would okay. I get it. Okay, it just my connections with there. Okay. What else? What else do we know about fractions?
It's part of whole.
It's a part of a whole. And then I may ask you a clarifying question. I'd say, how do we know how many parts are in the whole?
Usually my students will say denominator represents the whole, numerator represents the parts.
Okay, and there we go. I would just pull that information from our kids. Okay, so you're telling me that bottom number, or what we know as the denominator, is how many parts are in the whole. Am I correct? I see some heads going up and down. Okay, so I'd say, well, let's take another look at this equation here. And so if I have 12/13ths, am I correct to say that we have 12 parts of the 13? Okay, so we got a yes. And I say, so we almost have a whole at that point. Am I correct?
Yes.
Could I say the same thing about our 7/8? We have 7 of the 8 parts that make a whole. We're close to another whole right there. Is that a correct statement to say?
Yes.
Okay. So, how about if I pose this a different way? And I said this. What is your best estimate of 12/13ths plus 7/8?
Sure.
Would be 2. That's our best estimate. It's an estimate. It's not the exact number, but we know we should be getting kind of close to 2. If a student was to select some of these other numbers, what could we conclude about the student's thinking? What if someone selected C as their answer? What could we conclude?
I would. Do you want us to answer?
Yeah.
Oh, well, obviously they're adding the numerator, but I would conclude that maybe they don't understand what the word estimate means.
That's okay. So we would know they're most likely just added across. They added the numerators, and possibly they don't know what the word estimate means. Okay. What about if they selected D?
They
So-
added denominators.
The denominators. They just added the denominators. And so there's also power in the wrong answer. It helps you figure out, okay, what a student did, and why they got the wrong answer. So going back to the article, sometimes we want our students to get to that right answer, but we need to understand where their thinking was in order to help support them. And that's always something I would encourage you as teachers to do. Don't just, say yes, it's correct or not. Try to pull from your students where their thinking is. Let them explain it. And then you have a better way of differentiating your instruction for those students. Okay.
Because you recognize where the gaps are.
Yeah.
Right? You understand that they don't understand the word estimate. So you're going to circle back and do a mini lesson on estimation, or that they don't understand how the numerator and denominator are used, or whatever it might be. Let me just throw in real quick, Anthony, the way that he modeled that conversation for you by saying, what might someone who picked C be indicating to you, the teacher? That's also a great strategy to use with your students, to say to them, because I was big on process of elimination. I taught my kids some test taking strategies. And so we analyze these answers together before I told them the right answer, and say, why is might A be a good answer? Why might someone have picked C? Why might someone have picked D? And what you're doing there is you're encouraging empathetic thinking in math. You're asking kids to see something from a different perspective. You're not saying, who picked D? Why did you pick that? Because now you're putting that kid on the spot. But you're asking them to step outside of whatever answer they may have picked and think about that answer from a different perspective. So when you hear things like, we need to teach SEL across the curriculum, here's a way to begin talking about empathy in math class, to say, this answer makes sense if a student is thinking about this problem in this way. So it's just a cool way to kind of bring in empathetic thinking. And it works with any kind of multiple choice structure. So it works in any content area to ask students to analyze those answers from a different perspective. It's called the active, no E, ACTIV, active engagement method. And it comes from Robert Marzano. And that's really the idea, is that you're encouraging empathetic thinking in your students. Thank you, Anthony.
Can I just add in real quick, because I know we had some other new teachers that haven't taught before. I taught GED to adults for the last 10 years, and what I noticed was that, and many of them were there just for math. What I noticed was that they all have their favorite pattern, and so when you're looking for why are students, they're all saying, well, 9 and these add, or I can multiply these. So I know some of my partner teachers have said, I want to know what kinds of mistakes to look for. And that's one of the big ones, is they're trying to just create a pattern that makes sense to them.
Yeah. And if they're comfortable adding, they know that math involves adding, and they see a plus sign. So good, I'm going to add. and they're not extrapolating to say, hey, hold on, this is a fraction. I mean, so that gives you insight into their math thinking, that it stops at what they're comfortable and familiar with. And so we need to start opening up some different ways of thinking about numbers. Now let's circle back to that number line. That forced you to think about numbers in a different way because you didn't have a 0, you didn't have a 1, you didn't have perfectly drawn hashtags to help guide where you placed your number. So when I talk about flexible thinking in math, those are the kinds of things that I found my students typically lacked. They saw math as very linear. I do this, I get an answer. And really, things aren't that linear in life, right? And sometimes it used to drive me crazy on standardized tests when they'd flip the addition problem and put the answer first, and my kids wouldn't get it because the answer came first. It's like, guys, it's asking you 7 plus 3. We know what 7 plus 3 is. And so we started talking about the equal sign doesn't mean problem answer. The equal sign means that both sides are the same. So it doesn't matter the order. So I realize my students lack the flexibility in their understanding of that equal sign, and it caused problems that didn't need to be problems. So this today is about that math mindset, about setting structures in your instruction that allow for flexible thinking, productive struggle, great discussions, wondering, curiosity, all that great math stuff. All right, Anthony, I'm done for real.
No problem. Okay. Well, that's it. We want discussion. Okay. So with that said, if there's no more comments, I'm going to move forward. And thank you to those who have shared. So make sure your volume is up. We're going to share our first video for today. And this is just a misconception. Why did I slow down? It just sounded like my internet went unstable. I'm sorry about that. A short video. I do want to let you know that she's going to speak very fast. So clear your head and just be ready. And she starts talking right away. So this is our first video on math misconceptions.
Araceli, let's look at your work for a minute. I see you have the correct sum. 1/6 plus 7/9 does equal 17/18. But you placed your sum on the number line incorrectly, near 20, like this. You were thinking about 17 and 18 as separate whole numbers that are close to 20, right? Let's review what fraction notation actually means. We'll use an area model and start with a fraction that's easier to draw and visualize. 3/4. First, I draw one whole rectangle. For 3/4, the denominator is 4. That means the whole rectangle gets broken into 4 equal-sized parts, right? The numerator tells us we need to shade 1, 2, 3 parts of our rectangle to show that we need 3 1/4 to make 3/4. Now let's get back to our problem. We'll make another area model, this time for your sum, 17/18. Here's our whole, and since the denominator is 18, we'll break our model up into 18 equal-sized pieces. Now our model has 18 1/18. We'll need to show 17/18, so we'll color in 17 of those 1/18. That's a lot of 18ths, isn't it? In fact, looking at our drawing, we can see that almost the whole model is shaded. Let's look at the number line again. Here, our whole is 1. Like we did with the model, we'll break the area between 0 and 1 into as many equal-sized pieces as our denominator tells us we need. For this problem, our 1 whole is broken into 18 pieces, and 17/18 is not quite 1 whole. It's right here on the number line.
What are your thoughts on this video?
I'd never thought about students thinking that you would place it between 17 and 18.
I've had students do that. And that's back to that idea of familiar. I know the number 17, I know the number 18, so I'm going to stick with what I know. It's not that they aren't good math thinkers, they just didn't have that piece of their understanding yet. And they knew they had to put it somewhere, and those numbers were familiar. So I've seen that quite, not necessarily 17, 18s, but with 2/3, they put it between the 2 and the 3. And so I've definitely seen that as a student behavior. That's always interesting.
And you may see that more so with students when fractions are being introduced, when they're first learning fractions, too. Anyone else?
Good point.
The other thing I wanted to add was I really liked the video because a lot of times I feel like I can't demonstrate all of that in a timely manner. Like for me to shade in 17 out of 18 would take forever. So I like that it's already kind of set up for me, which is new to me because I'm kind of a dinosaur. I'm not from the Victorian era.
And that I like the visual. I like the way that she did that, how she expanded and showed this is part of between 0 and 1. That's one of my favorite parts of this video. And then the kids or students could see, oh wow, okay, this is what they mean when it's part of the whole. It's in between here, and how she expanded, So that was just something I like. This video, we have a link of this also. And then, again, it's just something there to give you some tools to add to your toolbox. You may use it, may not, but it is there for you.
It's in the shared folder.
In the shared folder.
It's just a great reminder to me at how important that visual representation is to share with our students to really help them connect. And so taking the time, picking out the problems from your math lesson that day that you anticipate possible misconceptions, and then being able to model and draw that for them is a great strategy to support all your learners in your math class.
We have Alyssa and Chitra who have their hands up. Alyssa, you want to share?
I was going to ask, is this Math Amplify in all grade levels? Because we use Amplify for reading, CKLA reading, but I was kind of wondering if it's also applies to like first grade, lower grades.
This is we found this, I think, on the Amplify, what is it, amplify.com is where we found the video.
I have to assume they have them for multiple grade levels.
Yeah.
I don't spend a lot of time looking for other grade level videos, so I can't say yes for sure, but I have to imagine they have across grade level resources because they're a publishing company, so it would behoove them to do that.
Chitra? Readers?
Muted. Yeah, I think she's muted.
Oh, you may still be muted, Chitra.
So, where can I find resource folder? I registered for the meeting, but I did not get the meeting link. Today I contacted the coordinator and I got the meeting link.
Okay. Yeah, we haven't shared the folder link, and the reason is because there's stuff that's coming that we don't want to ruin the surprise. But before the end of the session, we'll give that to you. And most of the things we're sharing, additional versions of the handout, some additional readings, is all in the folder. We just haven't done it yet, but it's coming, I promise.
Okay, thank you so much. Thank you.
Thank you for checking in. Our next, we want to just take a look at this. I want to start by sharing that the answer is correct. But I want you to really just kind of think real deeply and look at this and share with us how has the procedure algorithm affected this child's expression of learning. Again, the answer is correct. The algorithm that was used is correct. But just take a real hard look and just tell me anything that you noticed about what the student did. Okay, someone add something in chat. Let's see what that's. You wrote they did put a negative in their answer. Are you looking at this as? I think the answer is one. The question was 114 minus 72.
I'm sorry, I didn't realize it was 114. I thought it was integer problems because I'm algebra.
Okay, right. Okay, no problem. Oh, the X, maybe an X. Okay, okay. That's good. Okay.
Oh, even I didn't realize it was 150.
See, perception matters.
Yeah. Something popped up in chat again, Christine?
Yeah, it says child knows subtraction is from first number minus second number. They add, and then someone else said they added another number, and they probably still don't know to work with 2-digit subtraction.
And that's kind of where we're saying about this. The answer is correct. The procedures done here, you can clearly tell that they understand about regrouping, or let me not say they understand it, but they know how they show the work. When you look at this, and again, we don't know what the teacher asked them to. I mean, so these are some of the unknowns. But looking at this, in all honesty, was there a need to do the regrouping? So we've got two no's, right? And there really isn't. And that's why our question is, what is the child really, do they know the algorithm or do they have a good understanding about the number relationship? Because all they did in the regrouping is made an 11, which they had from the beginning. There was really no need to go through the regrouping process. And so, again, this takes us back. Even though our children may get the wrong number or answer, or even if they get the right answer, you can see oftentimes where they may have a gap in some of their understanding. And again, this is correct. It would be marked correct and all of that. We're not saying that. It's just that one of those you'd want to question and possibly even work with that child a little more, because they had 11. They went through all of this, crossing out, adding the 0, making it 11 again, and still had to do the same amount of work. So that's what we wanted you to see in this. That sometimes, even though our children get the right answer, are they doing it because they know the algorithm or the procedure at doing it? Or do they understand those relationships between the numbers?
It's a great reminder to not focus only on the answer and the correctness of the answer, but to look at the work and what it's revealing about the student's understanding. Even students who can get the right answer are demonstrating a gap in their understanding about the relationships with numbers. They didn't do anything wrong. The teacher didn't teach this wrong. They got the right answer. Like, all of that is right, and they followed the procedure we teach them. But as Anthony said, they had 11 and they made 11. So it was just an extra step that wasn't really necessary. True, it follows the algorithm. So, but it shows you that this student doesn't have a clear understanding of place value, number relationships, or whatever that might be. So look deeper than just, did they get the right answer? This is where having them show their work or explain their work is to your benefit as their math instructor.
And I'm looking at our time, and it's 10:05. But I would like to just show this next video, and then we'll break right after that. Okay? It's a short video, but I think it'll wrap up this portion, and then after our break, we're going to go into a whole nother sphere of the workshop today, if that's okay with you guys. And it's a short video, but I think it'll be a good place for us to wrap up, and then we'll jump into everything after the break. So make sure your volume is on in. And this is called My Favorite No. And this is, I mentioned earlier, Marie had mentioned something, and I want to see if she sees the connection to this. Because when you said it, I wrote My Favorite No. So here we go.
Hi, my name is Leah Alcala. I teach 8th grade math, and this is my warm-up routine that I do with my students almost every day. I call it My Favorite No. Okay. Good morning, you guys. Your warm-up is on the board. I'm going to hand out your index cards. I put a warm-up problem on the board, hand out index cards to all the kids, have them write their answer. I collect it, and then I sort it. And I say yes, no, yes, no. And I look for my favorite wrong answer or my favorite no, and we analyze that. 4 minutes to work on it. Everyone makes mistakes. We're going to see your mistakes, you're going to see my mistakes. But a mistake is your opportunity to share with me how much you understand. And if I don't know that you don't know something, I need to teach you before the test. The test is too late. And this is a great spot for me to teach you. Make sure your name is on your card. Put your pencil in your pencil slot and pass your cards to the center. I started my warm-up routine to replace clickers that a lot of classes are buying. So that was a clicker for each student. You ask a question, they lock in an answer. And then you look at your computer screen and you know what percentage of your students understand the problem. Well, we didn't have the money for that, so instead, okay, here we go. I thought, well, what if I gave everyone index cards, collected them real quick with their answers already written on it, and then I can just sort them as quick as possible and find out what percentage of my kids know the answer. No? Yes? Costs 40 cents instead of $15,000. Yes, so we have quite a few yeses and some very interesting no's. 1, 2, 3. I then took that a step further, something I couldn't do with clickers. 7. Look at the ones who are getting it wrong. How far are they from getting it right? And showing that work to the other kids. Okay, my favorite no. Someone wrote this. I say it's my favorite no because I want the kids to first of all recognize what they're about to see is wrong. And I want them to recognize that there's something good in the problem. Like there's a mistake, but it's my favorite no because it showed some good math. So that's the wrong answer. But they did some things that I love. What in that problem am I happy to see? We always talk about what's right first, so that if it's any student's work, they are like, oh, I did do that right. There's a mistake, but the mistake didn't ruin the whole thing. What do I like about this problem? Gavin.
Well, they distributed both with the 4x and the -2.
Very nice. And what? Today's lesson was on factoring, so I needed to make sure they understood how to distribute. They distributed, and what lets you know that they distributed? David?
How there are no more parentheses.
There are no more parentheses, and they didn't just drop the parentheses. So they're asked to distribute a term with a variable. They're asked to distribute twice. They're asked to distribute a term with a negative sign, which is often a very common mistake that kids make. And my students do not. Like, I have 3 years of CST data now to show that one mistake my students do not make is distributing a negative, which is amazing because they used to all the time. Distributing -2 to -6 is +12. And that was one mistake I was absolutely looking for and I did not see, which made me very happy. Not until the very end, as we've gone over different sections of the problem that are right, that I will then ask, okay, now what is incorrect? What does this person not understand? Where's the mistake? If I get a third of my class raising their hand, ready to tell me the mistake, it's pretty high engagement at that point. Mia?
Like 4x times 2x was 8x squared.
Very nice. This 4x times 2x multiplies to 8x squared. Can someone convince me of that? How do we know that 4x times 2x is 8x squared? My low-level students are very engaged. They feel like they're not getting penalized for being wrong. They're not being made fun of. I'm not looking at them. No, there's no peer pressure at this point. But they're like, wow, that's my mistake. And now I understand. It's very comforting. I mean, I feel very with my kids at all times. I'm not surprised by what they don't know. They're not surprised by what they don't know. It's how it should be. It creates more of a dialogue with me and them.
Thoughts on the video, on the process? What are some thoughts?
Marie asked in the chat about names on the cards. And so, yeah, the names were on the card, so the teacher knew who submitted it, but she rewrote it before she displayed it. So the name was never tied to whose mistake it was. That it's from Teaching Channel. I've also found this video on YouTube. So if you want to review that for yourself, Leah Alcala is her name. She has lots of different amazing strategies that there are videos on. So,
what were some other teacher moves that you saw in the class during the video?
Marie noticed all the positive framing in the conversation about the mistakes, the fact that it was a favorite no and things like that. So there was a lot of positivity associated with.
Yeah. Chitra?
Oh, I also noticed a lot of positive, and also I felt when the teacher said my favorite no, that gives an opportunity. The students are not afraid to make mistakes. So because she did not pick the right answer and she said, okay, that is my favorite, but she said my favorite no, which means students know something, it is easy for it to fill in the gap as well.
They were saying that's teacher talk. And another thing, she starts off with saying what was right, the things she wanted. Let's look at the things that were done right. So all of the students paying attention, okay, that was done right. She goes through all of that before she gets to the things where the student made mistakes. So it's letting those filters down with the students. Math tends to, again, make people anxious, especially if it's something they don't feel comfortable with. And so by doing that, everyone's figuring out, hey, this is pretty good. I did that right, at least myself. Some confirmation, help building the students' confidence. And that's something that's very important as well. I see, was there...
Someone asked about her name, so I did put the spelling of her name in the chat in case you want to make note of that.
Okay. And any other comments?
I liked all the authentic use of vocabulary.
Yeah.
Right? You heard the kids talking about distributing. You heard them using the language of the discipline. And I felt like that was a really powerful aspect of this strategy as well. We've got to talk about math in order to understand that vocabulary. And it was an authentic way to do that.
Thank you. That said, I think that we're at a good time to take our break. I have 10:15, and it'll probably change to 10:16 by the time I finish talking. So
let's go ahead and do 10:35. We'll give them a little extra time since we went a little long.
No problem. So we'll see you all back. 10:35. We're going to leave the room open. You can mute yourself or turn off your camera or whatever. But we'll see you in just about 19 minutes or so.